Okay, cool. So it's 11:10, so we'll go ahead and get started. So thanks for coming out. Today is going to be a conceptual review on lists and dictionaries, or the C88C midterm. Let's make sure everyone's in the right place. So yeah, so basically what we'll kind of do is we'll do a conceptual overview, kind of like a mini lecture on the two topics, and then we'll do some practice problems for each of them. Cool. So we'll first start off with lists. So, some basics behind lists. We declare them using square brackets. They can combine, or they can take in any combination of types, and they're zero indexed, meaning that the first element in the list is index 0. Sorry, there's a lot of noise over here. Just let me know if you can't hear. As for indexing into the list, we do it with this syntax here, which is the name of the list, right? Brackets, and then the index, the number that corresponds with the element you want out of that list. So first element of the list is at 0, and the last element is the length of the list minus 1, right? Because it's 0 indexed. And also a cool trick is that you can index backwards. So if you do list of -1, that's going to get you the last element, -2, second to last element, and so on. And if we see this example down here, we have kind of a simple, more one-dimensional list. Has 1, 2, 3, A, B, C. And then we see the second list, we actually use that list within the list itself, right? So the elements are 88, this list, and 8. And the effect that gives, and that's something called a nested list, right? And if we kind of look at this drawing, what that ends up looking like is my list 2, even though it has all these elements in my list, that's just one element in that list, right? So if you look at this kind of drawing of it, you can kind of see that my list placeholder is sort of just a reference to that list. It doesn't really just put all of the elements in the list. So if you were to ask for the length of my list 2, it would still be 3, even though there's a lot of elements in that original my list. Cool. Any questions so far? Cool. Okay. Here are some helpful things with lists. Creating lists, we do that with the bracket notation, right? If you want to find the length of the list, we can use this len function. And also, we have a very powerful in function, and that's basically going to give you a Boolean, a true or false, depending on if some value is in another list. Cool. And kind of like we were saying before, if you have a nested list like this, the length of this is just going to be 2, right? Because that second element is a reference to another list, not like that list, the list elements itself. Cool. All right. Here's some helpful functions, specifically for adding elements. So this is something that's pretty important. So we have here append, extend, and insert, right? So these functions don't return anything, right? All of these functions, they don't return anything. The goal of these functions is to actually modify or mutate the list that you call it on, right? So we do something like list.append1. This function is going to return nothing, but whatever this list is now going to have a 1 at the end of it. So it's very powerful. So if you're ever trying to create a new list, you don't want to be using these functions. These are going to mutate an already existing list, right? So we got append, we got extend, which will basically just put each of those elements, put each of the elements within the list actually in the list, right? Whereas append, if you pass in a list into append, essentially that will just make the list one element bigger, right? Because you're just adding a reference to another list, a nested list. But if you did extend, you're actually taking all the elements in that list and throwing them at the back of the list. So this would actually make it 3 elements larger. Insert will take in the index and the element that you want to insert. And once again, all of these don't return anything. They simply modify the mutate list. However, this one right here is actually a bit different. So this is the plus equals operator with lists. And remember that plus equals, you're always going to want to have the right side also be a list, right? You can't add 2 things that aren't lists together. And essentially, the list plus equals, that's going to have the same behavior as extend, in the sense that it's going to, if you were to do something like, does it have an example there? No. If you were to do something like 1 plus 2, 3, that would actually get you a new list of 1, 2, 3. right? So same behavior as extend, but very importantly, what this has done is it's, oh, that's strange. Okay, give me one sec. There we go. Hopefully that doesn't happen again. Okay, but importantly, it's created a brand new list, right? So whereas append and extend and stuff are going to modify this one and return nothing, this is actually going to create a brand new list, which is very helpful, especially with stuff like recursion, right? Where you want to be passing in a new list into like a recursive call. So it's very helpful for stuff like that. Cool. Any questions on anything on this slide? Yes? Yes, so if you go on Ed, I have a link to it. It's also at this link here. Go C88C org list review. So, oh, there, yep. And I'm also attempting to record this, so in case you want to rewatch this recording back or something. Okay, cool. So now move on to removing elements. So here we have the remove function, which is essentially going to take in some value, and it's going to remove the first occurrence of that value in the list. We also have the pop function, which is one of the basically the only list method that actually returns something, right? And what pop basically does is if you don't pass in any arguments, it's going to pop off the last element in the list. Like for this example here, where we have this list with the last element's 80, it's going to pop it off in the sense that it's going to remove it, but it's also going to return you that value, right? So before we had this 80, and then we popped it, and then now it's gone, right? And we also returned that value. You can also optionally pass in an argument into pop, which would be the index that you want to be popped out. And it's going to have that same functionality where it returns the element, but also removes it from the list. Cool. How are we feeling about all of this? Good? Okay. Awesome. All right, some other list functions. We have the min and max function, which do kind of what you would expect, right? They return the minimum or maximum of the list. A really cool thing about these functions, which you've probably seen in your maps project, is the idea that it can take in some key argument. And essentially what this key argument is going to do is it's a one argument function. And what it's basically going to do is it's going to call on, or it's going to call this function on each element of the list, right? So this lambda function, for example, which just gets you the square, is going to call it on each of these values in the list, and it will return you the minimum item that corresponds to the one that had the minimum output of that return function. So a good example is if we just did like min of -1, 0, 1, we would expect that to just be, we would expect that to just be -1, right? The minimum in the list, right? But if we did it with this key passed into it, essentially what that's going to do, this key lambda x times x, what that's now going to do is it's essentially going to loop over the list and apply that function to each of the elements in the list, right? So it's going to say, okay, well, that when you apply it to -1, you get 1. When you apply it to 0, you get 0. And when you apply it to 1, you get 1, right? And these blue values, and here I'll make the lambda function also blue for some color coding. These blue values, they're the outputs of calling that function, right? And that's actually what min is going to use in order to figure out what is the minimum value, right? But very importantly, it's actually not going, in this example, they're the same value, so maybe that's not the best way to show it, but it's not going to be returning the blue value that was the minimum. It's going to be returning the corresponding value in the list that kind of created that minimum value, if that makes sense. So it's still only ever going to return one of the items in the list, but that key function is going to be deciding which one that's going to return. How do we feel about that? Does that make sense? Cool. We also have our sum function, which give it a list, it'll give you the sum of all the elements inside of it. Cool, cool. Okay. Moving, oh yes.
Does the key function only work with min and max?
Ooh, good question. That's basically all we use it for in this class. I'm sure there's other functions that kind of utilize that same idea. But yeah, in the scope of this class. Yeah. Oh, sorry. I'll come back to you next.
When it says the return value is used for comparison,
Yep.
Does it return the original value or the return?
Great question. It returns the original value that corresponded to the minimum return value of the function. So it's only ever going to return one of these. Did you have your hand up? Yeah.
For the one argument function, is that always going to be a lambda function, or could that be a?
Great question. Not necessarily. The only requirement is it has to be a one argument function. So you could have done a def statement earlier and passed that in as well. Totally cool. Awesome. Great questions. Okay. Moving on, list slicing. Very cool. Essentially, list slicing is basically a way of creating a new list from or creating some new list that's a subset of some original list, right? So you'll see it written as this notation. And essentially what it does, or essentially what this does, is it's going to create a new list from index A, which is inclusive. So it includes index A, up to but not including index B, right? So the end is inclusive. So kind of similar to the range function, right? Where start is inclusive, stop is exclusive or non-exclusive. Same idea here, right? And you can also only do like part of the slice, if that makes sense. So if you wanted, you could also do like list colon B. And essentially what that means is A is going to default to 0, right? Or you can do it the other way around where it's like list A colon, and that's going to make it default to the length of the list, right? All the way up until the end of the list. So, I'm not sure what's happening here. Oh, okay, yeah. 1, 2, 3. Yeah, so if we look at this Joe list, for example, we could see that we want to slice from 1 to 3, right? So if we actually write these indices out, 0, 1, 2, 3, what we're all going to do is we're going to, remember the 1 is inclusive, so we're going to include part. We're going to include the 3, right? But we're not going to include true, right? Because it's exclusive. So the outputted list that you'll get is part and 3. So very valuable. And it's also important to remember that property, that it creates a new list. Kind of similar to like the plus equals, right? How that creates a new list. That's definitely an important property with list slicing as well. Yeah?
So index 4 would be like the whole nested list, right? Inside.
Good question. Yes, it would. Yep, because that Joe list just sees it as one element within its list. Yeah.
Is there like a step input, kind of like how range has a step input?
Oh, good question. I believe there actually is. Yeah, I don't think it's something we really use in this class too much, but I'm pretty sure, don't quote me on it, I'm pretty sure if you do another colon there, you can define a step. Yeah. But definitely not something you need to know. Yeah.
So list slicing doesn't modify the original list, it just makes a new list.
Correct. Yep, no modification in the original list, right? So same with that plus equals. Yeah.
So how would you access the new list? You have to define it again.
Oh, good question. Yeah, so like if we wanted this to be like our new list, you would probably want to just set that equal to some variable, right? So like new equals this Joe list, and then you can access it, yeah. You'll see this a lot with recursion with lists especially, and you've probably already seen it already, right? You deal with the 0th element, and then when you do the recursive call, you slice off the first one. You do that 1 colon. And that's very valuable for recursion because it returns a new list as well. Cool. All right. Awesome. Super cool property. Okay, and here's just a side-by-side of iterating through a list, right? List iteration. So on the left, you have a for loop. On the right, you have a while loop. So essentially, there's 2 ways to use a for loop to go through a list, right? You could loop through the indices, right? And if you're doing that, typically the way you'll see it is for I in range length of the list, right? And that's going to go from 0 up to length of the list minus 1, right? Which is exactly the behavior we want. So in this case, every time you loop through, I is going to be automatically incremented to the next value. And you can just use I as you would expect. You could also say for some variable in list itself, no range or anything, and that's going to actually pull the values in the list with each passage of the loop, right? So in this example, if we were, for example, if this was just ls, x would be equal to 20, then 30, then 40, etc. Whereas this one, I would be equal to 0, then 1, etc. Right? So looping through the indices versus looping through the list. It's the list elements. As for a while loop, if you're looping through a list with a while loop, the idea there is you're going to basically have to keep track of your counter, right? So typically the way you'll see it is you'll set some I equals 0. You'll say I is less than the length. And at the bottom of the while loop, you're going to do like an I plus equals 1. Where the for loop kind of handles that for you, so it's typically a little easier. But that's just something to know. So typically, you're using for loops when you want to iterate through a list, but it's definitely valid to use the while loop as well. Yes?
Is 0 modulo 2 0?
0 modulo 2? Yes. Yeah, pretty sure. Okay. Cool. All right, list comprehensions. So the objective behind a list comprehension is essentially we want to create some new list from some existing list, right? So basically the way it kind of works is it's going to step through some existing list element by element, and it's going to apply some expression to the element. So here's kind of the anatomy of a list comprehension, as you would. So first you have the expression. Now it's kind of weird because reading it left to right doesn't really make that much sense. So typically I like to start with like the for loop portion, right? So this part in the middle here, this is the part where it's using the existing list, right? So you're saying for x, whatever variable, in some original list, right? Basically, you're going to apply, or I guess we can read this if statement, right? If some condition is true, right? If x mod 2 is equal to 0, then you're going to apply some expression on that element and put it in the new list, right? So we'll see some examples for this, but if we were going to kind of walk through this, essentially what would happen is we'd start our loop. We'd say, and first x would be equal to 1. And you'll note that this is going to fail the if checker, right? Not divisible by 2, right? So what's going to happen is we're actually just not going to include it in our new list at all, right? It's never going to even run that expression. Okay, what about when x is 2? So that does pass our expression, right? So what we're going to do is we're going to say, okay, that's good. So now we're going to jump to our expression, and we're going to say, okay, then add 2 times x to our new list, right? So that's going to give us 4 in our new list. Then when x becomes 3, same idea, right? We're going to ignore it because it fails that if check. But then when x becomes 4, we are going to add it to our new list times by 2, right? Applying that first expression to it. And that'll kind of be the output. Yes?
Can you show what it would look like in non-list comprehension? Like in the regular one?
Oh, like right now it's a for loop? Sure, yeah, we can do that. So the way you'd kind of do it there is you would create some empty list, right? So I'll just call it new. And then you would do for x in 1, 2, 3, 4, right? So looping through the same way you would. And essentially, we're still going to have that if statement. If x mod 2 is equal to 0, then we're going to want to append 2 times x to our list. And that by the end of that for loop, that new list should be exactly equivalent to whatever list we get as an output of the list comprehension. It's a great question. Cool. How do we feel about list comprehensions? Awesome. Okay. So would you guys prefer to have some time to work through these examples on your own, or would you rather kind of go over them as a class? What do you think? Anyone have a preference? I'll give you guys 3 minutes to kind of work through these. So go ahead and give that a shot, and we'll go over them together. So around 3:32. And we can skip this last one, so don't worry about that. Just for the sake of time. Okay, so totally fine if you're not done, just for the sake of time, because still got to get to dictionaries. But let's go ahead and work through this one. Does anyone have an idea for how you would go about doing this first one there? The sum of my list sliced from 2 to 4. Oh, yeah?
So you start with the index of 2 and you end with the index of 3.
Okay, so
The final list would just be 0 and then 1 and then you would add it together to get.
exactly, right? So remember that the 2 is inclusive, so we start with that 1, and then we go up 2 but not including 4. If we had just also removed that 4, it would have been the exact same thing, right? It would have just gone to the end of the list. Cool. Okay. Does anyone want to take a shot at this one? Okay. No problem. Sure. Yeah, go for it.
Pop the first index last 2, just add it to the end of the list.
Gotcha. Yep, exactly that. So basically what's going to happen is my list pop 1 is basically going to remove the element in the first index in the list, right? So it's going to remove this 2 and also return this 2, right? Pop is one of the only list methods that actually returns something, right? And now this basically is just going to read as my list.append 2, right? And my list now has this 2 removed. So it'll look something like this. 3, 0, 1, 2, right? So that 2 is moved from the first index to the last. Cool. Okay. This last one here, basically what's going on here is we're saying for I in my list, get the do an index into the list, right? But this one's a bit tricky because we're not actually looping through the indices of my list. We're looping over the values of my list, right? Because there's no range here. So because there's no range, we're actually looping through the values themselves. So essentially what's happening is we're first going to say, okay, well, I is going to be equal to 3, right? Because that's the first element in the list. So what's the value at the third index? 0, 1, 2, 3. First one is 2. Then I is equal to 0. I'll just have be a pointer. I is equal to 0. So now it's going to be 3, right? The 0th element. And I is equal to 1. So now it's going to give you the element 1. And finally, wait, sorry. 0. No, it's going to give you 0. It's flipping me up, tripping me up. And then 0, 1, 0, 1, 2. No, I was right. That is 0. Then 2 is going to get you 0, 1, 2, so you'll get the 1 there. So a little tricky because they use the variable I, which we're kind of used to seeing for counters. But they're saying in my list, not range, so we're actually going through the elements themselves. Cool. Does that make sense to everyone? Cool. Okay. Awesome. All right. Last things I want to go over with lists is the map, filter, and reduce functions. Essentially, a map is going to take in some function and some list, right? Some sequence. And it's basically going to return a map object, which don't worry too much about. Usually, you'll just end up casting it to be of type list, and that'll work exactly as you expect. Map is actually like an iterator, which is not in scope quite yet. But basically all you need to know is that if you call list on the output of map, you'll get the list output of it. And essentially it's basically just going to apply some function that you pass in to every element in the list, right? So if you call map on square of some list, and this is your list, your outputted list after you cast it to type list is just going to be the square of each of the elements. So that is map. And then we have filter. And essentially filter, now the function is giving you a true or false value, right? So essentially what's happening here is we are going to return a new filter object, which is kind of the same as the map object where we kind of just want to put the list thing in front of it to get the list. And essentially it's only going to have the values where the function, when passed into the value, was true. So kind of similar to the key argument thing a little bit here, right? Because we're using the value of the outputted function. So in this case, it's only going to return us the positive numbers. Cool. And then finally reduce, don't worry too much about this, but basically the idea that you're going to be storing up some value that you're accumulating over time, right? by using some function. So essentially, an identity is basically the variable that's going to hold all of the values that you're building up. And essentially, let's say you wanted to have the multiplicative sum of everything in the list. Basically, what you could do is call this reduce function. Or I guess here it's doing the square root product. But kind of a similar idea, right? And basically what's going to happen here is you have your multiplicative identity set to 1. That way when you multiply on it, it doesn't if it starts at 0, then you're going to zero everything out, right? It'll just give you 0. But if you start at 1, then you can kind of start building it up. And what it's basically going to do is it's going to call this multiplicative identity, like square root product, is going to have x equal to multiplicative identity, and y equal to the first element in the list. And then, when it goes to the next element, multiplicative identity is set now to the output of that first function call. And on the left is kind of what it would look like if you were just doing it with a for loop. But I was kind of fast for right now, so definitely you check out that slide if you want to learn more now. But probably should start moving on to dictionaries. But any other questions before we do that? Cool. All right. Dictionaries. Kind of moving, shifting gears a bit, but they're pretty similar in that they're both data structures, right? The key difference with dictionaries is that instead of having just a collection of elements, now we're having a map sort of that maps keys to values, right? So dictionaries will contain these key value pairings, right? Like for example, this one, the key is 1 and the value is A, right? Key is 2, value is B. So there's two kind of main ways to initially create your dictionary. The first way is just to initially set up all the values inside of it, right? Just kind of like that. Another way is maybe start it as like an empty an empty dictionary, and then essentially add to it, right? And the way that you're going to add to a dictionary is you're going to put the name of the dictionary, bracket the key, and then set that equal to something. Don't get too caught up on this comma notation. Essentially what that's doing is it's a multi-line assignment statement. So that's assigning to this, that's assigning to this, and so on. But yeah, that's the main way you're going to be adding values to your dictionaries. And one thing I want to note is that keys have to be unique, right? So you can't have two key value pairs that both have the same key, right? If you try to do that, it's basically just going to overwrite whatever was there, right? So if I kind of try to come here and say D of 1 equals B, it's not going to like add a new key value pair, right? Because 1 is already in the dictionary, right? It's already here set to A. So it's basically just going to overwrite that value and now set it to B. So you can, if you want to store multiple values within a key, a usual technique is that you'll have a list as the value, the corresponding value in the dictionary. And also keys must be immutable, but we'll talk about that in the next slide. Any questions on anything so far? Cool. All right. So as for kind of the rules with keys and values, like I kind of mentioned, keys have to be unique and have to be immutable. And essentially what immutable means is it's basically just some data type that cannot be modified, right? So basically all you need to know is it can kind of be anything except lists and dictionaries, because you can append to a list or you can add new keys to a dictionary. But you could have immutable data as keys, no problem, including tuples, which are essentially just lists, but they're immutable and they use parentheses instead of brackets. Values don't have any restrictions. They can be whatever you want. They can even be dictionaries, no problem. Cool. Okay, and here's kind of just a mega slide on some functions and techniques with dictionaries, right? So first up, we have the in operator. And essentially by default, if you were to say x in dict, what that's going to do is it's going to see if x is a key in the dictionary. And that's a common theme you're going to see. Like for example, in this for loop, for k in dict, that's essentially just going to loop through all of the keys in the dictionaries. And it's the same as if you were to do something like dict.keys as a method, but totally optional. By default, Python will automatically loop through the keys or use the in operator on the keys. You can also use pop in a dictionary in the way you would expect, kind of like a list, except now you're passing in the key value, and the value that's going to return is not that key value, but its corresponding value, right? So In this example, if you were to pop 1, you would return A. Or B, I guess, after I changed it. So you're returning that corresponding value. Okay, the get function, don't have to worry too much about that. Essentially what that's saying is it's the same as just indexing into a dictionary, but you can set a default value so that if that key does not exist in the dictionary, instead of kind of throwing an error, it's just going to give you a default value, like a 0 or something like that, whatever you define it as. Dict.keys is essentially going to give you an iterable. Don't worry too much about that quite yet. Basically just something you can loop over. Same with values. So you can totally loop through the values of the dictionary by doing something like this, right? For value in dict.values. And finally, you can loop through the keys and the values simultaneously by looping through dict.items. And key is going to be set to that key, like whatever you put first here, whatever variable you put first. And value will be set to the value, or whatever variable is put second. Okay. It's kind of just info dump, but how do we feel about that? Cool, cool, cool. Awesome. Okay, oh, I guess that's all we have for dictionaries. Cool, okay. So, yeah, let's go ahead and we can start working on some practice problems. Let's go to this one. Okay, so let's try this problem out. So essentially, what we're going to be doing here is we're going to be writing, this is kind of like a list method, right? So the idea here is basically we're going to implement this subset sum function. And essentially what it's going to do is going to take in some list and some I, right? And basically it wants you to find the sum of all of the possible subsets that exist from I to the end of the list. So definitely easiest to see with an example. So if we look at this example, where it has the list 1, 2, 3, and starting at I, essentially what they want you to do is, starting at index 1, all of the possible subsets, sublists that are contained in that. So in this example, one sublist would be just a list containing 2, right? Just a value at that I. Another one would be the value 2 and 3, right? So those are kind of going to be your two sublists. And you're going to sum them all together so that it's eventually going to be equal to 7, right? 2 plus 2, 4, 4 plus 3, 7. This is because the two subsets of the list starting at index 1 are 2 and 2, 3. And you can assume a valid index will always be passed in. Definitely check out these doc tests as well to give you a little bit of a better idea for this question. But yeah, I will give you till, let's say till 11:49, 11:50-ish. So go ahead and give that one a shot. All right. So totally okay if you're not done. That wasn't very much time at all. But does anyone maybe have an idea about how you could kind of start to approach a problem like this? Or maybe some techniques you might use? Yeah.
I wasn't able to finish, but I wanted to create like a for loop, and if the index is less than the length of the list, and I wanted to like append it to an empty list where it was like the index slicing according to the index at the beginning and the length of the list, and then we subtract the length of the list each time until like I guess if the index was like equal to the length of the last list and so on.
Gotcha. Yeah, I think a strategy like that could definitely work. Yeah. I'll go ahead and kind of model like maybe one way to do it. So definitely you're dead on with the idea of using list slicing. That'll be very helpful in a problem like this because essentially we're trying to get subset lists from some bigger lists, right? So a strategy we could do, maybe let's create some variable total, right? And that's basically going to be our total sum. And that's what we're going to eventually return in this function, right? So now if we think about what we want to do, essentially we want to have all the slices from I, so whatever the value of I is, all the way up until the length of the list, right? So in this example here, it has 1, 2, 3, 4, 5. It starts at 2, right? So 0, 1, 2. It's going to start at 3. Then it's going to do 3, 4. Then it's going to be 3, 5, right? So if you kind of think about it like this, the I is kind of always going to stay where it is, right? We always want the sublist to start at 3. But you can almost think like maybe we have some like, I'll just call it j, some j variable that's extending, right? So initially, it's set equal to the same as 3, right? Where we just have the list containing 3. Then it's going to move to 4, right? So now we have that list 3, 4. Then it's going to move to 5. So now we have that list 3, 4, 5, right? And we can essentially almost do the for loop for that j variable, since that I is kind of locked in place. So what we could do is we could say, okay, for j in range, and this is going to be a bit tricky, so we have to think about the rules for list slicing, right? Because we know we're going to do a list slice. If we want the first element to be just a list containing 3, what would that slice look at, right? Let's say this variable's named list. What slice of list would get us a list just containing 3? Well, that would be 3, 4, right? Because remember that ending bit is non-inclusive. So the first value we want j to be is whatever I is plus 1. Because we want our first list slice to be that, right? We want it to be 3, 4. So that way we can just get that element on its own isolated. Let me see, and that gives you a list of 3. Cool. As for the ending value, we want it to go all the way to the end of the list, right? So we want j to go all the way up to the length of the list, right? So we want j to go from I plus 1, j to go to I plus 1 to the length of the list. Since we're using range, a bit tricky, since we're using range, it's also going to be exclusive, right? So if we want j to go all the way up to the length of the list, then the second value passed into range needs to be the length of the list. Is that what it's called? Yeah, length of the list plus 1. So that's our for loop statement. That way j's first value is 4 in this example, and j's last value is, which example is this? Oh, that was this one. And j's last value would be 5. Okay, cool. Now, what we're going to basically do is, for whatever slice we're at, we're going to find the sum of that. So I'll just call it cur, as like current sum. And basically what we can do is we can do our list slice and wrap it in a sum, in a sum function call. So if we do our list slice to make it list of I, remember that I is never going to change, but the j is going to be changing, right? We're going to be looping through that. Now that's going to give us the sum of whatever list that we pass into that. And that's basically like our current sum, the one we're currently on. So the idea there is we can now add that to our total. Total plus equals cur. And then by the time the loop has fully run through and finished, that total should be equal to that sum of all the subset lists. So we can simply write out here, return total. And that's the solution to this problem, or at least one of the solutions. So using a bit of a few things we learned, including the list slicing and the sum and stuff. Yeah. Any questions? Yeah.
Can you re-explain why you do length of list and then the +1?
Oh yeah, over here? Yeah, so the only reason for that is because we want the last value of j to be the length of the list, right? Because list slicing also is exclusive, right? So the problem is range. If I were to just do this, right? If I just say I plus 1 length of the list, the highest value j is ever going to be is length of list minus 1. Because range is also exclusive, right? So by adding this +1, I ensure that j can get to the length of the list value that I want it to be. Hopefully that makes sense. That's a good question. Yeah.
On the actual midterm, are they going to give us skeleton code for this, or will we have to run it all out?
Great question. You'll definitely get skeleton code on the midterm. Yeah, which can help. In the next problem, we'll have some skeleton code, which is a good indication of what you might see. But yes. Okay, cool. Did we get it right? Looks good enough for me. Okay, cool. All right, and this is the last one we'll get to today. We might go a little bit over time, so definitely no worries if you want to head out. Essentially, what's going on here? This is a dictionary-related question. Essentially, what's going on here is we're managing orders for a restaurant, and we have some function add new orders, and that's basically going to take in some dictionary all orders, which is all of the orders that we've accumulated up until this point, and we're going to mutate it to include the new orders from the list new orders. So each element in this new orders list is a tuple, where the first element is the food item, and the second element is that item's quantity. Okay, so typically reading a problem like this, it doesn't really make much sense. But it might start to make sense when you kind of look at these doc tests, which is highly recommend doing it on the exam, right? Just reading the problem, usually you don't really feel like it enough to kind of start to jumping into code. So if we look here, this is our starting out, our initial set of orders, right? So it's a dictionary where the key is the food, the value is the number of orders, right? Then we're calling this add new orders function, the function we're creating on this order dictionary, right, as the all orders, but we're passing in new orders, which they said is a list of 2-element tuples, right? And we see that here, right? So here's our list, and this list has 2 elements, which are each of these tuples, right? And each of those tuples, the first value is the food item, and the second value is the quantity, right? And remember, tuples are just lists that are immutable. So you can treat them just as lists with indexing and stuff. And yeah, I think I'm just going to probably have to just go over this one. I don't know if I'll have time to work on it. But essentially, so we have some skeleton code here, which is what you'll see on an exam for the most part. And if we look here, I think we would kind of expect to see some kind of for loop, right? Because we're going to want to be looping through the elements in our new orders list of tuples, right? But if we look at the skeleton, it looks a little strange, right? We don't have any for loops anywhere. And it looks like we have a call to the same function that we're in right now. So those are some clues to tell you that this function actually kind of wants you to write it recursively. Bit of a dual thing going on here where we're dealing with recursion as well. So those are kind of some clues that might stick out to you. So now this makes you kind of reevaluate, oh, so maybe this is kind of like a base case. So let's maybe ignore the base case for now and think about how we might go about doing this problem. So the value that we're dealing with is this new orders list, right? And typically when we're recursing through lists, a general strategy is kind of you're getting a little mini recursion thing, I guess, but deal with the first element in the list, and then recursively call on every on list with first element popped, essentially. So that's a typical strategy, right? And I think that's definitely a strategy that'll be helpful for us here. So with that in mind, let's just treat the first element of the list. And if you look, the skeleton actually kind of gives that to you, right? It says the food item we're dealing with is new orders of 0, right? Which is basically saying the first element of the list, right? Which is this tuple, right? Fries and 4. So if you're getting a little confused on that double 0 statement, the only reason for that is because each element in the list is a tuple itself. which is also, you can think about it as like a list, where we also need to get that first element. So we're given the food item and we're given the quantity, right, of the 0th element. And what that's kind of giving us a clue for is, okay, we're going to deal with the first element, and then when we do our recursive call, we're going to slice off that first element, right? Okay, so what's this if-else statement then? Well, with dictionaries, we're going to have kind of two behaviors, and that's depending on whether or not our food item already exists in the dictionary or not, right? Because if we're adding fries, and fries already exists, what we're going to do is we're going to take the value and add it to whatever the value is in there, right? We don't want this to become fries 4. We want it to be adding to the 3 to make it 7, right? We want to be building up that value. But if it's a brand new key, a brand new food item, like milk here, like milk here, there's nothing to add it to, so we're creating that key value pair. So there's two different behaviors there. So what that kind of gives us a clue for on the if-else is essentially, okay, well, is this food item already in our all orders dictionary, right? So what we could write is if food item in all orders. And remember, the in operator looks at all the keys in the dictionary, right? So if that is true, that means we already have that key value pair, right? So in that event, all we want to do is update its value, right? So what we want to do is we can say, okay, well, in that case, all orders of food item, because now we can guarantee that this key value pair exists in the dictionary, right? Hopefully y'all can read that all right. So essentially when we do this, we're grabbing that corresponding value, in this case 3 if we're going to pretend we're dealing with fries. And what we want to do is we want to add the quantity of the new order, right? So we're going to say plus equals quantity. And we can do that plus equals because that value already exists. However, the else case would be the exact same thing, except instead of adding to an already existing value, we're going to be setting its initial value equal to the quantity. And this is a common strategy you're going to see with these kind of dictionary problems, where you kind of have that if and then the else, right? Depending on if the value is in the dictionary or not. Okay, and then finally we'll get to the recursive case, which, so we'll get to the recursive case. Now we've already updated our all orders, so we're going to pass that along to our next function call, right? All orders, since it has those updated values in it. Does anyone have a guess on maybe what we would pass in for new orders? Oh, yes.
Maybe like you start at index 1, so you take out index 0, and then you go to the last element, and then you use a call and you leave it as it.
You got it, exactly, right? We dealt with the 0th element, so on our future recursive calls, remember recursion, we always want to call it on a smaller subproblem. So we're going to do new orders of exactly like you said, colon, or bracket 1 colon, right? And that's essentially going to do the recursive call on everything else besides the first element. And then finally, the only thing I left till the end is the base case, because usually base cases are easier when you know what your recursive case is going to be. In this case, we know that we're chopping off one element one at a time, right? So the simplest case of this problem would be when the list is empty, right? There's no orders to deal with. So a lot of ways you could write this. I'm just going to say if the length of new orders is 0, then we have nothing to do. We just return. And that is the full solution to this. And that, and that concludes today's conceptual review. And feel free to ask any questions. I can hang out for a few more minutes, but yeah. Yeah, good question. So like on these two lines, right? Yeah. So the idea there is basically we want to be updating our all orders dictionary, right? In this example, the order one that we pass in, right? So basically, when you want to add, let's just deal with the case where we're just adding the new value in the dictionary, right? Essentially, what we want to do is to create a new key value pair. You do it with a line that looks like this, where essentially you have the name of the dictionary, the name of the key that you're going to pass in, and set that equal to the value that you want that to be. So it's not so much that we're like trying to get the value at that entry because it doesn't exist yet. But we're actually, this is the line of code to create the new key value pair, if that makes sense. This one up here, it already exists. And that's why we can do this plus equals, which is essentially just saying is equal to this plus quantity, right? You can only do that if this already exists, right? Because otherwise it's going to be like, well, I don't know what the current value of it is. But in this one, we're not counting on it already existing. We're just adding that new element in. Okay. Oh, that's only because they set it up here for us. Yeah, good question. Yes?
So food item is like the key, per se?
Yes, exactly. And you can look at that here, right? There's our key, and there's our values, right?
Okay.
So in that kind of model, the food is the key and the quantity is the value. Okay, do you have something? Okay. That's okay. All right. Any other questions?